Hello. Today I thought I would discuss the doubts raised in the NPTEL video, but as far as I have seen, the video is very clear. So I thought I would like to add few points on diffusion. Diffusion is a process carried out to create source drain regions in MOSFETs in the ICs, and this diffusion process is carried out at very high temperature, and for this we need a chamber like this where the dopants in the form of gas will be entering and the impurities will diffuse from region of higher concentration into a region of lower concentration. So here on the wafers are kept on a board like structure, and whole thing is placed under a very high temperature of the order of 1000 degrees centigrade. The diffusion process is of three types: substitutional diffusion, interstitial diffusion, interstialcy diffusion. In substitutional diffusion, as we see here, the impurity atom occupies the lattice portion of a regular silicon atom, and then under the influence of temperature, this impurity atom moves and occupies another lattice position, and there is change in the concentration of impurity in that particular point. In the interstitial diffusion, the impurity atom occupies the intermediate position and jumps from there to another intermediate position, gaining energy, and in case of substitutional diffusion and interstitial diffusion combined, the impurity atom which was in the regular lattice position will jump into intermediate position. So the impurity atom becomes interstitial, leaving behind a vacancy. In kick-out mechanism, what is happening? The impurity atom which is in the intermediate position will, under the influence of high energy, will knock out the regular silicon atom from its lattice structure and occupy its position, thus pushing this regular silicon atom into intermediate position. In interstialcy diffusion, the impurity atom which is in the regular lattice position jumps into intermediate position and then again to the regular lattice structure here, knocking out the silicon atom. Thus, we saw the three types of movements of diffusion. Thank you.